Hello, everyone. I want to tell you about a man who changed the world of science. But first, I want to tell you about a man who opened locks he was not supposed to open. His name was Richard Feynman. And during one of the most secret projects in history, he was picking locks. Let me take you back. It is the middle of World War II. The United States government has gathered the greatest scientists in the world. They are all working together in a small town in the mountains of New Mexico. The place is called Los Alamos. The project is called the Manhattan Project, and the goal is to build something that no one has ever built before. Everything at Los Alamos is secret. The files are locked. The safes are locked. The buildings are locked. Security is everywhere. The government believes that no one can get in or out without permission. But Richard Feynman is not like other people. Feynman is young. He is just in his mid-20s. He is already very smart, and he already works at Princeton University. But what makes Feynman different is not just how smart he is. It is how he thinks. He does not just accept things the way they are. He always asks why. He always asks how. And then he goes and finds out for himself. One day, Feynman looks at the metal safes in the office. These safes hold top-secret documents, papers that no one is allowed to read without permission. And Feynman starts to wonder. He wonders how safe are these safes really? So he starts to study them. He reads about how combination locks work. He practices again and again. He learns to feel the tiny movements inside the lock. And slowly, he learns to open them. Not by force, not by breaking anything, just by understanding how they work. Then he starts opening them. He opens the safe of one scientist. He opens the safe of another. He leaves little notes inside. Notes that say things like, "I borrowed this document," or "Guess who is here?" The scientists come back to their offices, and they find the notes. They are shocked. They cannot believe it. Their top-secret safes are not safe at all. Now, some people might ask, why would he do this? Was he trying to cause trouble? Was he just being funny? The answer is both. But there is something deeper happening here. Feynman believed that if you do not understand something completely, you do not really understand it. If the people at Los Alamos believed their documents were safe, but they were actually not safe, that was a problem. A real problem. Because real enemies could do what Feynman was doing. And those enemies would not leave funny notes. So Feynman was not just playing a game. He was teaching a lesson. He was saying, do not believe something just because someone tells you it is true. Test it. Check it. Find out for yourself. This way of thinking, this need to check everything and trust nothing without evidence, this was at the heart of who Feynman was. And it showed up in his science too. At Los Alamos, Feynman worked with some of the greatest minds in history. People like Niels Bohr and Hans Bethe. These were serious men. Important men. Men who had spent their whole lives studying physics. And when they had a problem, most people would stay quiet and listen. But not Feynman. Feynman would argue. He would push back. He would say, wait, I do not think that is right. And sometimes the greatest scientists in the world would have to stop and say, you know what? Feynman has a point. Hans Bethe, one of the leaders of the project, actually chose Feynman to work closely with him. Not because Feynman was quiet and easy to manage, but because Feynman was honest. When Bethe made a mistake, Feynman would say so. And that made the work better. There is one more thing I want you to know about this time in Feynman's life. Because it is not a happy story only. While Feynman was at Los Alamos, his young wife Arlene was very sick. She had a serious illness called tuberculosis. She was living in a hospital not far away. Feynman would drive to visit her on weekends. They would talk. They would laugh. They would solve puzzles together through letters in the mail. Even in such a hard time, Feynman did not stop being curious. He did not stop being playful. But he also did not pretend that everything was fine. He carried his sadness quietly, and he kept working. Arlene passed away in 1945, just before the project ended. And Feynman sat alone and cried. For a long time, he could not cry. And then one day, walking past a store, he saw a dress in the window. A dress that Arlene would have liked. And the tears finally came. This is the full picture of Richard Feynman at Los Alamos. Not just a funny man picking locks, but a deeply feeling human being. A scientist who tested everything, who trusted nothing without checking, who argued with the greatest minds in the world, and who loved deeply and lost deeply, and kept going anyway. That is who we are talking about today. Now, let me take you somewhere warmer. Somewhere with music and dancing and the sound of drums by the sea. After World War II, Feynman becomes a professor at Cornell University. He is respected. He is successful. People know his name. But something is wrong. Feynman feels stuck. He sits at his desk and he tries to do physics. But the ideas do not come. The joy is gone. He feels pressure to do great work. He feels pressure to be brilliant. And that pressure is like a heavy stone on his chest. He cannot breathe. He cannot think. He starts to wonder if he will ever have a good idea again. Then one day in the university cafeteria, Feynman sees a student throw a plate into the air. Just a regular dinner plate, spinning and moving. And Feynman watches the plate spin. He watches the way it wobbles as it spins. And something wakes up inside him. He starts to think about the physics of that wobble. Not because anyone asks him to. Not because it is important. Just because it is interesting. He works on the math of the spinning plate. For no reason. Just for fun. And that small moment, that one spinning plate, helps him find his way back to himself. Around this time, Feynman gets an offer. The offer is to spend time in Brazil at a university in Rio de Janeiro. And he says yes. Brazil changes everything. Rio de Janeiro is full of life. The streets are loud and bright. The music is everywhere. And Feynman, this serious physics professor, walks into that world with open eyes and open ears. He hears samba music for the first time. Samba is a kind of music from Brazil. It has a strong, fast rhythm, and it makes you want to move. Feynman listens, and he loves it, so he decides to learn. He finds a group of musicians, and he asks if he can join them. He starts to play the bongo drums. At first, he is not very good, but he practices every day. And slowly he gets better. He goes to rehearsals. He goes to street festivals. He plays with the band at Carnival, the big yearly celebration in Brazil. He is not Richard Feynman, the Nobel Prize physicist, at these moments. He is just a guy playing drums with his friends. And that is exactly what he needs. But Feynman does not only play music in Brazil. He also teaches physics. And when he looks at how physics is taught, he is not happy. He notices something. The students can say the words. They can repeat the formulas. They can write down the right answers on a test. But when Feynman asks them a simple question about the real world, they go quiet. They do not know. Feynman asks a student, when you look at light coming off the surface of water at a certain angle, what do you see? The student knows the name of the law. He can write the formula, but he has never actually looked at water and thought about what he sees. Feynman calls this kind of learning a cargo cult. He uses a story to explain. During the war, people on small islands in the Pacific Ocean saw airplanes land and bring wonderful things, food and medicine and tools. After the war, the airplanes stopped coming. So the people built fake airplanes out of wood. They built fake landing strips. They waved signals, hoping the planes would come back. They did everything that looked like what happened before. But the planes did not come, because they had the form of the thing but not the substance. Feynman says that is what some education looks like. Students learn the words. They learn the form, but they do not understand the real thing underneath. He believes that real understanding comes from looking at the world, from asking questions, from noticing things, not just from reading books or memorizing facts. This is something he practices himself every day in Brazil. He walks on the beach and he looks at the waves. He sits in a cafe and he watches the way people move. He listens to the drums and he feels the rhythm. He is learning all the time, but not from a textbook. One day, a friend asks Feynman why he plays the drums. Is it not beneath a man of his intelligence? Should he not spend his time on more serious things? Feynman thinks about this. And then he says something very important. He says, I get the same feeling from figuring out how a drum makes sound as I do from figuring out the universe. The joy is the same. The curiosity is the same. The size of the problem does not matter. What matters is the pleasure of finding things out. That phrase, the pleasure of finding things out, becomes one of the most famous things Feynman ever says, because it captures something true about how he lives his whole life. He is not driven by fame. He is not driven by prizes. He is driven by a simple, deep, never-ending joy in understanding things. Whether it is a spinning plate in a cafeteria, whether it is the rhythm of a samba band, whether it is the mystery of a tiny particle moving through space, the curiosity is always the same. The joy is always the same. And Brazil is where Feynman remembers that. Let me tell you about a moment that millions of people watched on television. A moment that changed how many people think about science and truth, and the courage it takes to say something that powerful people do not want to hear. It is January 1986. A space shuttle called Challenger lifts off from the ground in Florida. Millions of people are watching. Children are watching from their classrooms. Parents are watching from their homes. It is an exciting day. There is even a teacher on board, a woman named Krista McAuliffe, who was chosen to be the first teacher in space. 73 seconds after launch, Challenger breaks apart in the sky. All 7 people on board are gone. The whole country is in shock. The government forms a special group of experts to find out what happened. This group is called a presidential commission, and Richard Feynman is asked to be part of it. Feynman almost says no. He is not well. He has kidney problems. He does not like committees. He does not like politics. He does not like the slow and careful way that official groups talk about things without saying anything real. But his wife Gwyneth tells him, if you do not go, you will regret it. So he goes. And from the very beginning, Feynman feels something is wrong. Not just with the shuttle, with the investigation itself. The official leaders of the commission want to move carefully. They want to follow a process. They want to talk to the right people in the right order. But Feynman does not work that way. Feynman goes and talks to the engineers directly. The regular engineers. The people who actually build the parts. And what they tell him is very different from what the managers say. The engineers are worried about something called O-rings. O-rings are small rubber rings used to seal the joints of the rocket boosters. They keep hot gas from leaking out. They are a very important part. The engineers tell Feynman that they have been worried about these O-rings for a long time. They know that cold weather makes rubber hard. And when rubber is hard, it does not seal properly. And the morning of the Challenger launch, it is very cold in Florida. much colder than usual. The engineers had tried to stop the launch. They had said, "It is too cold. We are not sure the O-rings will work." But the managers said the launch must go on. And so it did. Feynman listens to all of this. And then he does something very simple. During a break in one of the big official meetings, Feynman asks someone to bring him a glass of ice water. Just a regular glass of ice water. And a small piece of an O-ring material. He puts the piece of rubber into the cold water. He holds it there with a small tool called a clamp. He lets it sit in the cold water for a few minutes. And then he takes it out. The rubber is stiff. It does not spring back. It does not return to its normal shape quickly. Feynman holds up the rubber in front of the cameras and the reporters and the officials. And he says, "I believe this has some significance for our problem." That is it. No long speech. No complicated math. No difficult words. Just a piece of rubber and a glass of cold water. But everyone in that room understands. If the O-ring becomes stiff in cold temperatures, it cannot seal the joint properly. And if the joint is not sealed, hot gas leaks out. And if hot gas leaks out of a rocket booster at full speed, the result is disaster. In a few seconds, with a glass of ice water, Feynman shows the world what went wrong. Now, the story does not end there, because Feynman is not just fighting to find the cause. He is also fighting to tell the truth. And that is harder. The official report from the commission is careful. It is polite. It talks about the problem with O-rings, yes, but it does not say clearly how badly the system failed. It does not say clearly how the warnings of engineers were ignored. It does not say clearly how the risk of the shuttle was being presented in a way that was not honest. Feynman refuses to sign the report unless his own words are included. He writes his own section. And in that section, he writes something that many people still remember today. He writes that for a technology to be successful, reality must take priority over public relations. Because nature cannot be fooled. Nature cannot be fooled. What does that mean? It means that you can tell the public whatever you want. You can hold press conferences. You can write beautiful reports. You can say everything is safe and everything is fine. But if the physics is wrong, the physics is wrong. And eventually, reality will show you the truth. You cannot talk your way around it. You cannot manage your way around it. You cannot hold a meeting about it and make it different. The rubber got cold. The seal failed. The shuttle broke apart. Reality did not care about the schedule. Reality did not care about the pressure to launch. Reality does not negotiate. This lesson is so important. And it goes far beyond space travel. In any field, in any job, in any part of life, when people are under pressure, there is a temptation to say things are better than they are. To say, we are probably fine. To say, let us not worry about that now. To not listen to the person who says, wait, something is wrong here. Feynman spent his whole life fighting against that temptation. Not because he wanted to cause trouble, but because he believed that the truth, even when it is uncomfortable, is always better than a comfortable lie. And the Challenger investigation is the clearest example of that. A man with a glass of ice water and a piece of rubber. A simple test, a simple result, and a truth that the whole world needed to hear. Now I want to talk about something that might sound very difficult at first. But I promise by the end of this chapter, you will understand the basic idea. And you might even think it is beautiful. After the war, physics is changing fast. Scientists are trying to understand how light and matter interact at the very smallest level. This area of study is called quantum electrodynamics, or QED for short. It is one of the most precise and powerful theories in all of science. But it has a very big problem. The calculations are almost impossible to do. When physicists try to calculate what happens when two electrons interact, the math becomes so complicated, so full of steps, that it takes pages and pages of work. And even then, it is very easy to make a mistake. The numbers spiral out of control. Some calculations give answers that are infinite, which means something has gone wrong. Feynman is not happy with this. He believes that if something is true and real, there should be a way to understand it clearly. If the math is a mess, maybe the way of thinking about the problem is also a mess. So he starts to think differently. He asks a simple question. What if instead of writing out all these long equations, we draw a picture? A picture, not a complicated picture. A simple diagram, lines and curves and small symbols, where every line represents a particle, where every curve represents light or a photon, where every point where the lines meet represents an interaction, a moment where things come together and something happens. These diagrams become known as Feynman diagrams, and they change physics forever. Here is the basic idea. Imagine two electrons, small particles with a negative charge. They push each other away because they have the same kind of charge. Now, in the old way of thinking, you would write out a very long set of equations to calculate what happens. You would add up many different possibilities, and it would take a very long time. With a Feynman diagram, you draw a simple picture. You draw a line coming from the left for the first electron. You draw a line coming from the right for the second electron. Between them, you draw a wiggly line to represent a photon, a tiny packet of light that passes between them and carries the force. And that picture, that simple drawing, tells you the whole story of what is happening. Each diagram represents one possible way the interaction can happen. To get the full answer, you add up many diagrams, but each one is clear. Each one is simple. Each one you can look at and understand. When Feynman presents this idea at a conference in 1948, not everyone understands right away. Some of the greatest physicists in the world are sitting in the room, and at first they are not sure what Feynman is doing. It looks too simple. It looks like a shortcut. It does not look like real physics. But then other physicists check the answers. And the answers are correct. More than correct. They're the most precise answers anyone has ever calculated. The Feynman diagram method works better than anything else. And slowly, physicists everywhere start to use the diagrams. They learn the language. They put Feynman diagrams on their blackboards, in their papers, in their textbooks. Students all over the world learn to speak this new visual language. Today, if you walk into any physics department anywhere in the world, you will see Feynman diagrams on the walls. They are one of the most recognized images in all of modern science. But here's what I think is the most beautiful part of this story. Feynman did not invent the diagrams because he wanted to create a new tool. He invented them because he was frustrated, because the old way of doing things was not clear to him, because he could not understand something unless he could see it, feel it, picture it in his mind. He once said that he cannot understand something unless he has a kind of private picture in his head. Not just a formula, not just a word, a picture, a story, a way of seeing. And that is so deeply human. Most of us learn better when we can see something, when we can draw it, when we can tell a story about it. Feynman understood that about himself. And instead of forcing himself to think the way everyone else thought, he trusted his own way of thinking. And his own way of thinking turned out to be one of the greatest gifts ever given to physics. There is one more thing about the diagrams that I love. They did not just make the calculations easier. They changed how physicists imagine the world. Before Feynman diagrams, Physicists thought about particles as tiny little balls moving through space. With the diagrams, they started to think about particles as characters in a story. Electrons go out, they exchange photons, they change direction, they create new particles, they destroy old ones. The quantum world became something you could almost watch, almost follow, almost understand with your eyes as well as your mind. That is the power of a good picture. I want to end today with a question. Not a question about physics. Not a question about rockets or particles or diagrams. A much simpler question. When did you last feel truly curious about something? Not curious because you needed to know for a test. Not curious because your boss asked you to find out. Just curious. The way a small child is curious when they see a bug walking across the ground and they get down on their hands and knees to look more closely. That kind of curious. Richard Feynman never lost that feeling. Not when he was young. Not when he was old. Not when he was sick. Not when he was famous. He carried that feeling with him every single day of his life. And I think that is the most important thing about him. More important than any prize he won. More important than any diagram he drew. More important than any safe he opened or any drum he played. He stayed curious. Always. Let me tell you about a conversation Feynman had with an artist friend of his. The artist said to Feynman, "You scientists take something beautiful and reduce it to a set of numbers and equations. You take a flower and you reduce it to chemistry. You take a sunset and you reduce it to light waves. You take all the beauty out of the world." Feynman thinks about this. And then he says, "I think you are wrong. When I look at a flower, I see everything you see. I see the color. I see the shape. I see the beauty. But I also see more. I see the cells inside the flower. I see the process that makes the color. I see the way insects are attracted to that color, the relationship between the flower and the world around it. I see the mystery of how something so beautiful could come from something so small. Understanding does not take away the beauty. Understanding adds to it." This is one of the most important things Feynman ever said. Because there is a common idea that science and wonder are opposites. That if you know how a rainbow works, it becomes less beautiful. That if you understand how a bird flies, you stop feeling amazed by it. Feynman disagrees completely. He says, knowing more gives you more to wonder about. The deeper you go, the more amazing it becomes. The more you understand, the more you see that there is still so much you do not understand. And that is not a frustrating thing. That is a wonderful thing. Feynman was also a great teacher. And what made him a great teacher was not that he knew more than other people. It was that he could explain things in a way that felt alive. He did not just give you the answer. He took you on a journey to find the answer. He made you feel what it was like to not know something, and then slowly, step by step, to start to understand. He once said that if you cannot explain something simply, you do not really understand it yourself. This became a famous idea. People call it the Feynman technique. If you want to learn something, try to explain it in simple words, the way you would explain it to a child. If you cannot do that, go back and study more. Because real understanding is always simple at its heart. The complications come from confusion, not from depth. He applied this to his own work too. When he was developing his ideas about quantum electrodynamics, he kept asking himself, can I explain this simply? Can I find a picture for this? Can I tell a story about this? If the answer was no, he kept working. He kept thinking. He kept looking for a simpler, cleaner way to see the truth. And this is something all of us can do. In any field, in any job, in any part of our lives. When we understand something truly, we can say it simply. When we are confused, we use big words to hide the confusion. Feynman had no patience for that. He wanted the real thing, the simple, honest, clear understanding. Feynman also had very strong ideas about what it means to have integrity as a scientist. He believed that a scientist must always try hardest to prove themselves wrong, not to prove themselves right.
Wrong.
Because proving yourself right is easy. You look for the evidence that supports what you already believe. You ignore the evidence that does not fit. You tell yourself a comfortable story. But proving yourself wrong is hard. It means looking at all the evidence. It means being honest about what you do not know. It means saying, I thought this was true, but I was wrong, and here is the evidence. It means caring more about the truth than about being right. He called this a kind of scientific honesty, and he believed it was rare. He said that the first person you must not fool is yourself. And you are the easiest person to fool. Read that again slowly. The first person you must not fool is yourself. And you are the easiest person to fool. This is true in science, but it is also true in life. We tell ourselves stories. We believe what we want to believe. We see what we want to see. And Feynman spent his whole life fighting against that tendency. In his work, in his investigations, in his teaching, in his everyday thinking. In the last years of his life, Feynman becomes sick. He has kidney cancer. He knows he does not have much time. And people ask him, are you afraid? Are you angry? Do you wish things were different? And Feynman says something that stays with me. He says, I have had a wonderful time. I have loved figuring things out. I have loved the world. I have no complaints. He dies in 1988. He is 69 years old. And his last words, spoken very quietly, are, I would hate to die twice. It is so boring. Even at the end, he is himself. Honest. A little funny. Completely without pretending. So, what do we take from his life? What can we carry with us? I think we take this. Curiosity is not a gift that only a few people are born with. It is something we can choose. Every day, we can choose to look more closely. We can choose to ask one more question. We can choose to say, I do not know, but I want to find out. We can choose to see the world the way a child sees it, with open eyes and an open mind, not because we are naive, but because we know that the world is far more interesting than we have time to fully understand. Feynman did not just study nature. He loved it. He played bongo drums because the rhythm was interesting to him. He picked locks because he wanted to understand how they worked. He drew diagrams because he wanted to see the invisible world with his own eyes. He sat in front of a committee with a glass of ice water because he believed that the truth was worth saying, even when it was hard. He was not a perfect person. He was difficult sometimes. He was stubborn sometimes. He made mistakes. But he was always, genuinely, deeply, joyfully curious. And that curiosity made him one of the greatest scientists who ever lived. Not the other way around. Not the greatness first and the curiosity second. The curiosity was first. Always. The curiosity was everything. So the next time you see something you do not understand, do not look away. Get a little closer. Ask a question. Try to figure it out. You do not have to be Richard Feynman. You do not have to win a Nobel Prize. You just have to be willing to look. And to wonder, and to ask why. That is where everything begins.